should be -2. So this one here, you pick on the little guy. So I'm going to move the cosecant from the right to the left. At the same time, I'm going to move the 17 from the left to the right. In doing so, I'm going to get cosecant of x equals -2. Now, if I go back to what you were saying earlier, if I want to rewrite that in terms of the inverse, this is the exact same thing as saying sine of x equals 1/2 negative.
Oh, because that's what I did, and then I didn't know if the half, because you can't have a -2. Right, because that's the...
Then you have to remember that this is over 1, and your negative value can float.
Oh, so, yeah, because that's what I was asking, because if it wasn't the 2 on the bottom, then that wouldn't be possible.
But remember, your negatives just means that the negative floats. For what? So, yeah, the cosecant is fine. Yeah, this is perfectly fine. Because that just means that your sine value is negative, so you're either in the third or fourth quadrant, and that just means that you're looking at you're here at, what is that, 30. So you're going to be at 7 pi over 6, 11 pi over 6. And you flip her away.
I got that right. I don't know why that's surprising.
It should surprise you.
Wait, and then so for 7 pi over 6,
This is longer.
number 2 on the side.
This is general, correct?
Yeah.
So this one I'm going to add 7 and divide by 7, and I get the secant value equal to 1. Which means I can do this one of two ways. I can do the secant value of 1, or I can do the cosine value of 1, because they're the same. All right? So if I think about this in terms of cosine, what angle has a cosine of 1? Because the reciprocal of 1 is just 1. Now that means, where is cosine 1? Well, cosine is your x value, because cosine comes before the word sine. So your cosine is positive. It's 1 at 0. Is it 1 anywhere else on the unit circle? No. So your answer is 0 plus 2 pi n.
Wait, are we going to have a diagram where we're taking the test or no? Can I have you just scratch paper so I can draw it from over?
It takes too long. You don't need to. You never needed
It
it.
just helps me like visually see like, okay, this is what.
You can draw it out, but you don't need it. That's what I'm trying to get you guys to realize. You never need it. You never need it. Because what's opposite? What are your silence of 36 and 90? Where does the root 3 go?
I draw it on my eraser.
That's all it is. Because everything boils back down to the idea that, guys, everything boils back down to the idea that you only have 3 angles.
It always messes me up though, like when you have to do fractions like 11 pi over 6, like writing those out.
I got you. But you can draw it. I'm not giving you one.
Okay, so if you remember all that, you can just write it down in your notes.
I don't care if you do. It's going to take you time.
It would take me time.
Like,
Like,
there's
there's
no
no
use
use
to
I'm sorry, I can't hear.
I have a
What?
question about this problem.
Yes, ma'am.
So you said you could solve it using the secant, or you could switch it to cosine. How
Yeah.
do you do it with secant?
Well, what I would do is, knowing that secant is going to be my hypotenuse over my adjacent,
Yeah.
in order for it to be equal to 1, where is my hypotenuse adjacent the same? 0. Same thing. Because where is your adjacent, your hypotenuse the same? Keep that out. 0. Yes?
Oh, I was just wondering for the testing quiz tomorrow, like, is it gonna be like focused on this? Because you said.
I will tell you. I'm getting there.
Oh, so that's like the only thing you will tell us.
Of course. Oh, this is more fun. What else we got on this? Everything else not too terrible with this, is it? Yes, sir. You got $1? You should be. All right, I might as well. Whatever. I got Nelson to do. Was it on the A or the B side?
A.
Okay. Oh, sorry, I did the wrong one. Now, this is about as goofy as what we're going to get for right now. When we come, after we go back, yes, sir? The decimal.
You said it?
Did I? Oh, fine. So, as you get into these, the only thing that I'm worried about with you guys as far as what are called Pythagorean identities for trig is the only one that I'm going to put on there as of yet is the idea that cosine squared plus sine squared is 1. The reason that cosine squared plus sine squared is 1 is because when you go horizontal, that's your x value. When you go vertical, that's your y value. Well, we know horizontal is cosine, y is vertical, and the radius of the unit circle is always 1. So that's why we say that it's cosine squared plus sine squared is 1. So whenever you see sine squareds and a cosine, or on the other hand, cosine squared and a sine, you always wanted to rewrite the higher degree trig function in terms of the lesser degree. So if I have a sine squared and a cosine, I'm going to rewrite sine squared in terms of cosine squared. Right, because we know that the identity tells me that cosine squared plus sine squared is 1. And for some reason, people freak out about this. But if I say solve for x, what do? You get x equals y minus 1, okay? If I said solve for y, you would move the x. You'd get y equals 1 minus x.
Is there any rule like that for tangent?
Yeah.
Okay. We're just not gonna learn.
Not yet. Not yet. Because when we get through trig identities after we come back, then we'll go back and do some more equations with some more tricky stuff. What's that? So here I can say that right off the bat that 2 times this quantity 1 minus cosine squared is 2 plus cosine. All I did there was I substituted in sine squared equals 1 minus the cosine squared, just by moving the cosine over. You okay with that? What you're doing is you're manipulating what's called a literal equation. And I know that all of you guys have worked with distance equals rate times time. If you wanted to get rate by itself, you divide by time. If you wanted to get time by itself, you divide by rate. You manipulate a literal equation. So now you distribute. And I want to set one side equal to 0, and I also want to have my first term positive. So I'm going to take everything from the left and move it to the right. So 2 minus 2 is gone. Add this over, and I'm going to wind up with 0 equals 2 cosine squared x plus cosine x. And I think this turns out to be the same problem we did earlier.
Yep. Why do they all like wind up turning out the same?
Because how many angles are there? 3.
Yeah. Okay.
There's only 3 angles. There's only 3 ways that these things are going to wind up.
Incubus.
I was going to make it.
Boy, and there's the.
Where were you making that?
There's your other one.
Tape ball.
Take ball.
You just said why'd you make a tape ball?
I got bored.
Oh.
Wait, what is that?
It's heavy.
Isn't that a tape breakfast?
Wait, is it just all tape?
There's a small child's brain.
That's what I thought. That was
It's the tears of my Algebra 2 students from last year.
What?
It would be a bigger.
I wasn't trying hard enough.
My tears.
Do you want me to finish that, or is it real okay? 'Cause it's the same thing we did earlier.
You know what? That's
I don't like it when people go by and then they watch you through a window.
I know. Why do they put
Probably about the size of your heart.
maybe a bit?
No way.
Your heart's the size of your head.
Yes.
Try that one.
It's like half the size of your head. What? I don't know.
Oh, geez, I really can't wait up. Hey, I've written a lot worse than that before on there when I write abbreviations for sine, cosine, secant x, cosine x. Yeah, there's a lot of things get accidentally written up there. So that's why a lot of times I don't use the letter x. You could probably figure it out. You have to have everything done by Friday. Yeah. All you world travelers, you guys are okay to do this by Fridays, but everything's got to be done by Friday. Okay.
What do you mean by everything?
You got to be up to speed by Friday.
You don't think everybody turn in like everything? What homework
So in this case here, what's your first rule? What's the first thing you got to do? Okay. Take out your GCF and you take out tangent. Now what do you do? Ah.
Oh, you can take the square root of it.
Ah.
The cube. I think this is difference of squares.
Difference of squares. I'd have to like. So yes, polynomial style factoring comes back to play from time to time with trig.
Yay.
Now you have, guys, now you have three terms that you'd have to set equal to 0 to try to solve for x. So you have tangent, well, what angle has a tangent value of 0? What angle has a tangent value of plus or minus root 3? And, oh wait, can't do that one, can I?
No, because it's imaginary. Why is it imaginary?
So what's the square root of -3? We are not worrying about complex trig. Gotta save something for you guys for next year. Okay, I get it. I say a lot of the same things over and over again. I get it. It's predictable. Pretty soon I'm going to clap and say, I know you guys can do this. It's very similar to what we've done in the past. It's just one step further.
No, you're going to say, really, it's so easy.
No, I didn't say it.
You guys always like explain the most complicated thing.
We're gonna be all crying
That's all we're doing here.
It's only solving the mystery of
I hope that's all we're doing here.
It's only solving the mystery.
That's all it really is. Find a solution to x.
Well, x equals y at pi over 4. What? Do I need to finish that?
Yeah, I do. Wait until this.
Tangent is y over x, and this is what you guys were asking about earlier. In order for it to be y over x, and you get a 0, that means what has to be 0, the y or the x? The y. The y has to be equal to 0, so y equaling 0 is at 0 and at pi. All right? So you'd have 0, if I did it, yeah, it'd be 0 plus pi n or 0 comma pi. The other one, tangent, plus or minus root 3. Well, root 3 means you have your opposite is the root 3, your next to is that, so it's going to be at your 60, which means that is at plus minus gives you all 4 quadrants of up how many? 3.
Pi over.
So if it was list all, you'd have to go through all your pi over 3s. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. If it is general, pi over 3 plus pi n, 2 pi over 3 plus pi n. By all means, use your arms. You feel like a traffic person. Yes, they do. Well, I've shown you that. Oh, I don't have the tracing answer. What's
Oh, you have shown us that picture before though, like of the Nancy person.
Doing it again.
what is a positive slope? Use your arms to do a positive slope. What is your negative slope? What is x squared? Negative x squared. X cubed. Negative x cubed. See? It's just yes. Everybody walks in and just starts going. You start doing the you guys remember rerun? What's happening? Rerun dance?
I would have to watch it.
Yeah, put it on.
The Quizam. Sounds good. It sounds better than a quest. Because then if he says quest, I'd say, what is your name? What is your quest? It's just, what?
Oh my gosh, I got it. Wait, what is this? Yeah, what are you I told you, gotta experience But they're in chapter 10.
Good luck on chapter 10, ladies and gentlemen. We're back to quadratics and conics. That's
No!
Alright, so as we went through these things, as you go through what we're looking at in terms of what we've done, we've kind of finished up the idea of 14.4 being putting everything back together. The first one, the main jump we did in 13.2 was the idea of ordered pairs. How are they placed and how do you find the sine, cosine, tangents, and all that kind of stuff, and their inverses off of an ordered pair. You place it, and then you do the Pythagorean theorem, and go from there. After that, we started talking about angles and radians. This was your coterminals.
What is the arrow?
I have stuff here. We had that. You have a book?
No, we don't.
Shut up, you do too. It's called the internet. Alright, I'll do this.
That's not like a hard copy book.
Well,
You want something to say?
yes it is.
Those half of us.
Anyway, it was this stuff.
I did that on
Rewrite degrees, radians, that's just boring. But we also did draw angles, find coterminals. Coterminal angles, you'd have one positive, one negative. The biggest trick with positive and negative coterminal angles was if you started beyond revolution. That's all it was. I'm not putting on here quite yet the whole arc length and area of the sector stuff because you need a calculator. I'm not that nice.
Are we gonna maybe,
Nope.
Will you please give us like 1,000 something and like finding how many rotations? I don't know.
No, but I can give you something like 17 pi over 4.
Oh, I can.
Well, yeah, but I mean, like some of the
Yeah, like if you give me like
they have like,
yeah,
like chances are I'm gonna mess with that like rotation.
wait,
I'm going to make you dizzy.
180.
Fleming, you had a question.
Yeah, she does. She does.
I'm gonna need.
do you have to use the formula for the conversion?
Yeah.
Or is it just gonna be like?
You can just figure it out if you want.
But are they gonna be hard enough that you need?
I don't know.
When do you? Did you not take the quiz yet?
I don't know.
Are you gonna answer every question you're asked? I don't know.
Maybe.
So no. This? I'm in this.
Reference angles. Reference angles wound up being, if not, Reference angles, bless you. Reference angles wound up being one of the most important things that we talked about because it told you where things bounced within the quadrants. And as you understood where they bounced within the quadrants, we knew which angles we were working with. When we were dealing with reference angles, we first started, I was just asking you guys to figure out what they were to get you in the habit of doing so. Reference angles are always measured off of which axis? X. Very good. Yeah, down, up, wherever. Things like that. So as you go through, reference angles are just measurements off of X. We didn't really worry about so much of working with trying to finding what the trig function of negative 440 was. We would just figure out what its placement was and go from there. We didn't worry about doing trig until we got to numbers that made sense. We worried about trig as we got to cotangent of 11 pi over 6. We knew that 11 pi over 6 because we would spin that around. 11 pi over 6 got you into the third quadrant and you were down pi over 6, which meant you were at a reference angle of 30 degrees, and you figure out what is the cotangent of 30 degrees. You would draw the triangle and write it out. Optimal.
Is this where the ones where we found all 6?
You didn't have to find all 6 of this. This just says, hey, what's the cosine of that?
Okay.
All 6 trig functions was like an ordered pair. If the ordered pair was 2, negative 3, what's all 6 trig functions? Then you'd have 2, negative 3, you'd square the 2, square the negative 3, and find your radius and go.
Wait, how do you?
How do you do that one?
Oh, yeah, those are just X and Y values, so it's fine.
Well, it goes around
No,
2
not-
and
Not
5.
53, it's like 45. How do you do that better?
45? Cosine of 315. 315, as you come around, gets you to the third quadrant. You're 45 degrees off, so if you're down 45 degrees, there's your reference angle. Is cosine positive or negative in the fourth quadrant?
Positive.
It's positive. What's the cosine of 45 degrees? Root 1 over root 2, root 2 over 2.
Okay.
That's what
I
we were
was
doing.
like
And you guys, this is what you've been doing all along. You know what these values are because you had to figure that out to solve the equations. Because after we got through stuff like this, I just worded it backwards in 13.4. 13.4 changes it. Yeah, they changed it up to ask you what angle has. What angle has. Now, this is where it was different. Different from when you're solving equations. When you have something like this, or cosine of theta equals 1/2, you basically had to take the inverse of both sides. And this is the one and only time when you did this that you had to make sure you were looking within the specific quadrants that they told you to look for. Whereas when you were solving for anywhere on the unit circle. When you did something like this, because you had the theta in it, cosine, you were looking for values between 0 and pi. If it was a sine,
Is this 13.4?
yeah. If it was the sine of this, you'd be looking at pi over 2 to negative pi over 2. And if it was tangent, you were pi over 2 non-inclusive, negative pi non-inclusive, because the tangent value of pi over 2, negative pi over 2 is asymptotes. It's
But
undefined.
0 isn't.
But 0 is correct. So close.
You missed again.
I'll get over it. What's that? How would I finish solving it? Well, cosine 1/2, that means my adjacent is the 1, my hypotenuse, so that means this has to be the 60, so my answer would be pi over 3 or 60 degrees. That's all it would be. Okay, that's all that would be. Yes, ma'am?
So do we need to know anything with reference angles?
You already know everything about reference
You
angles.
have to, I think I know everything.
If you think about it, you already know how to use, and that's why that's why I kept showing like almost daily how you use a reference angle, because if you didn't know how to use a reference angle, you wouldn't know how to do any of this. And that's kind of my trick to teaching trig, is to beat you over the head with a reference angle. And hopefully that works. Well, all right. Yes, sir.
The question is, what's a whole angle?
Oh, I have some review problems for you guys here. And then obviously the tangent when you just go through the other quadrants in it as well. No, because a lot of those you have to use calculators for, and I'm not going to bother with it. Okay. What I did here is I actually found these in a file. Like, oh, look at this, there's some review problems. You guys have all the equation junk? Oh, did I give you one sheet or two? into your sheets.
Well, like some like do the review section for like you know in the book
Sorry.
they have like review for 3.2
So what I did is I actually had these left over from last year. I don't know why.
Yes.
And honestly, the only thing that I couldn't find more of that I didn't have lying around was this stuff from 13.4. So if you go back into the 13.4, really all you have to know is that if it says tangent of theta is negative 1, that means that you are looking for tangent values between here and here, pi over 2 to negative pi over 2, which means you're going to find tangent in the fourth quadrant, but it's not technically fourth quadrant because this is pi over 2. That's negative pi over 2. What's that angle then?
You're one short
Which one?
of the.
So find the exact.
Oh, there's a whole pile.
Oh my God, so what would that be? What angle has tangent values that's 1? 45. So this means if I'm going negative, I'm negative 45 or negative pi over 4. Remember, that's the only time that tangents, sines, and cosines that you're only looking for in a specific realm. If it's written out where you have tangent theta equals something, it says value it like that. If it's solved for x, that's when you open up to everything.
So those would all be less than 180 or maybe 180. Do you have the answer sheets?
I have the answers for the manually printed one. I do not have them for the handwritten one. And I think I just got lazy and just didn't write it. But here's the answers to the printed one. I believe I already posted it. I think I did.
Okay. What's the one where you can't go above and
Sine and cosine.
what?
And why?
Is that just for like?
What's the maximum value of x and y on the unit circle?
It says find the exact values.
It's like what case is that when you're finding like 14.4? It's so blurry.
Brain. Oh, are you thinking? All right. I thought you were just asking in general why is the sine or cosine bigger than 1? Sine or cosine, the values of sine and cosine will never be larger than 1 or smaller than 1 because the unit circle, the largest it goes is 1 or negative. That's it. Now, I think what you're asking is when you're solving for because what you're thinking is this, is when you have the sine of theta is negative root 3 over 2. Let's say you're doing that. When I'm seeing this problem, it's not solve for x or on an interval, it's not saying solve for general solution, it says what angle has that. When it's this, that's when you're looking at, well, sine is found between pi over 2 to negative pi over 2. This is the negative root 3 over 2, so that means my opposite went down the negative root 3. There's my 2, so this means this has to be the 60. So it's negative 60 degrees or negative pi over 3.
Don't worry about it. First and second, you'd only use that if you're finding.
Yep. The other ones were solve on the interval between 0 and 2 pi, or solve. And don't worry about the secant stuff. You're only going to, with these, secant is going to follow the same rule as cosine, so between 0 and pi. Cosecant follows the same rules as this one. Okay, cosecant of negative 2. That means the same thing as what angle has a sine of negative 1/2.
So if that were to say like cosecant of 30 off the quadrant or
but you can do secant of 2.
Oh.
Because secant of 2 is the cosine of a half.
Wait.
We got Jamie.
I was gonna ask, for this, what form should we put it in? Pi or like
2/-.
Well, I would go radian.
so you want it, yeah, so you want it like that. So just like pi, like.
Well, no, because it says what's the cosine. No. That's just what's the cosine of 35 pi over 6. What's the answer? 35 pi over 6. 6 goes to the 35 how many times? 1 little, 2 little, 3 little pi's, 4 little 5, 5, 6. Pi over 6 reference angle.
Oh,
So,
that's what you want to try to reference.
but what's the cosine value at that?
Oh, okay, because like for cosine 225, I got 45 degrees.
I don't know which problem you. I can't hear you over me talking. So.
Number 1 is cosine 225.
Okay.
And so you get like 180 and then 45.
Yes.
And so you just write 45.
No. What is the cosine at that angle?
Yeah, so it'd be 1/.
Okay.
You might want to go back and double check when we did this. Well, hold on.
So, like, the one on the border.
Guys, ladies and gentlemen, I have a feeling that more than one of you are going to ask the same question.
So, the one on the board right there,
Yeah.
like, if it gave you that sine of theta is -√3/2, and it said what angle is this, it's asking the reference angle?
No, it's asking what is the theta value that generates. It's not reference angle. It's different.
Oh, okay, that makes sense. But if you were to find, like, the reference angle for that, would it be, it would be just 60, it wouldn't be -60?
It's going to be -60 because you went down. So it's going to be -60 degrees or negative pi over 3. That would be your answer. Okay. So and what we're getting at with here is that as you spin this around, this is different. What is the cosine of this? Cosine of this gives you a pi over 6 leftover, which means you're working with a 30-degree angle, which is your -1, and this is your √3, and there's your 2, which means your cosine at that value would be √3/2. So the answer to this is √3/2. That's what that means. Okay. So you're placing. That's when you would spin it to win it. You place the angle in there, find the reference angle, draw the triangle, and write out the trig function. That's where that means. Okay. There's a lot of little nuances to a lot of this stuff, so you might just want to revisit the subtleties. Subtleties. Is it subtleties? Subtleties. That's why I teach math and not English.
SMRT.
Something. All right. What do you ask? Which one?
I don't need you to do it on the board. I just have a question.
What do you got?
Okay, so why is that? So the answer is something like -√3. Why is that a -√3? Because you go around this way and then up here. I said that's
Well, 600 is.
I just had a message. It's in there. Thanks.
Did you get a picture of that?
I think so.
So 360,
Then you have 6.
540, 60.
Oh, okay, so okay,
You went the wrong way.
I did go the wrong way.
You went too much.
I did. All right, and then
You got overspun.
Yeah, and then so
That's why it's negative. Because tangent's negative.
it's
Second
like
part.
a mess.
What else we got?
No brains.
Opposed.
Yep. For the reference angle, it can be like for that one, the answer would be -60, except if it's just like.
It's a regular reference angle. Reference angles are always positive.
Where did you find that?
Yeah, you're in Sadie who's covered. Oh, this one's well,
That's short. Bounce on bounce though.
It's covering 9 to 15.
Do. I gotta register my kid.
All right.